visualizing patterns. Before you start the lesson, make sure you find a quiet place and a notebook and a pencil that you can work and do problems. Also, make sure that you, on your browser, have an extra tab open and you're logged into your ConnectEd account so that you can follow along as this lesson moves forward and do the activities on the ConnectEd platform. Moving on to the objective. Students will be able to generate sequences, identify relationships between corresponding terms, and graph points on a coordinate grid to visualize patterns and relationships. So a lot of detail in this objective, but as we move forward in the lesson, we're going to begin to break down the objective in a way that is more digestible to hopefully achieve complete understanding at the end of the lesson. Let's get started. To start the lesson, we're going to begin by reviewing 3 of 6 vocabulary words. The first 3 are sequence, terms, and coordinate grid. In the first image, you see the sequence of numbers, the list of numbers 3, 5, 7, and 9. In this sequence of numbers, we are trying to identify the pattern. What is happening as the numbers grow from left to right? Below that, we have the word term, or terms in this case because there are multiple terms. In the expression 4x minus 7 equals 5, you see that there are 3 terms here, and the terms are the numbers and symbols as you see above. And then finally, on this page, we have coordinate grid. And we're very familiar with coordinate grids. This is quadrant 1 of a coordinate grid. And you see the term here, the coordinate A, which is 3 on X, which goes horizontally from left to right, and 5 on Y, which goes vertically from bottom to top here, making the coordinate pair 3, 5. Before moving on from this page, make sure that you copy these terms in your notebook so that they can help guide you through the lesson as you continue to hear the terms. Moving on to the final 3 vocabulary words for today's lesson. Here we have corresponding terms, relationship, and column. So corresponding terms are terms that are in the same position in a sequence of numbers. In the image, we see that 9 and 18 are in the same position, just as 3 and 6 are in the same position, 6 and 12 are in the same position, and 12 and 24. In the highlighted or circled corresponding terms of 9 and 18, they're in the same position because they have a relationship. They are connected. Below, that leads us into our next vocabulary word, relationship. It's the way in which 2 or more ideas, things, or people are connected. And then finally, our last vocabulary word is column. And a column is a way to describe up and down. Okay, boys and girls, we're in today's math message. Again, you can do one of 2 things here to follow along or work along. You can take out your notebook, or you can open another tab, as stated at the beginning of the lesson, that you will then log into your ConnectEd with your username and password as you follow along with this lesson. On the left-hand side, you're going to see that you have an in and out table. This in and out table is something that you've worked on in everyday math in 2nd grade, so you should be familiar with this. On your in column, moving up and down, you have 1, 2, 3, 4, 5. On your out column, you have 2, 4, 6, 8, 10. Now, these terms are corresponding, and they have relationships that we're going to begin to explore in more detail. So let's start off with A. I'm going to read A, B, and C, and then I'm going to give you some time to think about these prompts, questions, and have you respond in your notebooks or on your Google or ConnectEd platform. So here we go. A, what rule could you use to find the next number in this pattern, this sequence? 1, 2, 3, 4, 5. B, what rule could you use to find the next number in this pattern or in the following sequence? 2, 4, 6, 8, 10. And then finally, if you look at in and out, the terms in each row, what rule relates to in and out numbers in the table? Okay, let's go ahead and take a look at the patterns in the sequences for A and B and the rules for the in and out corresponding terms. So here we go. If I go ahead and take take a look at the sequence 1, 2, 3, 4, 5 on my in column, I can then go ahead and proceed with the next numbers in the sequence, which in this case would be 6, 7, 8, and moving forward, we could continue the pattern by adding one whole to each corresponding number. So the rule is +1. Now, if I proceed to go to B, what rule could you use to find the next number in this pattern? 2, 4, 6, 8, 10. So this one is slightly trickier. And here we can just analyze our first two terms and find the relationship. But we can see that they're both even, and that 2 to 4 increases by 2. We then go to 4 to 6. We also see that there is an increase by 2, 6 to 8 by 2, 8 to 10 by 2. So this suggests that the next set of numbers in the sequence are 12, 14, 16, and so on. The rule for B would be +2. So you're adding 2 to each new whole number in the sequence. Now finally, C, what rule relates the in and out numbers in the table? So as we had in our vocabulary review, we can see that 1 and 2 are corresponding. They are in the same horizontal position. So that suggests there is a relationship. 1 and 2. We can see that 1, to get the 2, is you would have to add by 1. So let's go ahead and take a look at the corresponding terms 2 and 4. 2, to get to 4, you would add. Now let's take a look at the next corresponding terms, 3 and 6. And in 3 and 6, you see that you are, again, there is an increase here of 3. 4 and 8 has an increase of 4, and 5 and 10 has an increase of 5. One rule that I could highlight between the in and out is that they are doubling. So every time you start with in and you go to out, the rule could be multiplying by 2. And any time we develop a rule, we want to test to see if that rule works not only for one set of corresponding terms, but all the corresponding terms. 1 times 2 is 2. 2 times 2 is 4. 3 times 2 is 6. 4 times 2 is 8. And 5 times 2 is 10. We're going to be using these skills to, again, let's go back to our objective, analyze in and out tables so that we can identify patterns. Then we're going to use those patterns to graph points on a coordinate grid to really visualize relationships. Okay, as we move to the next part of the lesson, this is just a review on how to analyze a table, in and out table, and then once we have decided on the relationship and the rules, to form ordered pairs that are then graphed on a coordinate grid, on an X and Y coordinate grid, quadrant 1 in this case. So let's go ahead and just take a look at the example here. Enter the numbers in the table as ordered pairs, where the in numbers are the X coordinates and the out numbers are the Y coordinates. Okay, so something very important here. If we take a look at the coordinate pairs here, 1 and 2, it's really important to know that as the coordinate pair is listed, 1, 2 with parentheses, that we acknowledge that the first coordinate pair, in this case it is 1, where the first coordinate is, or goes on the X axis of the coordinate grid, and the 2, the second pair or ordered pair, here is on the Y axis of your coordinate grid. Okay, so now let's go ahead and I'm going to just write the ordered pair here for 2 and 4. 2 and 4 being, again, vocabulary word, corresponding term. And then in your notebook, go ahead and give it a shot and write 3, 6, 4, 8, 5, 10. Okay, now let's go ahead and create the graph from the ordered pairs that we have listed above. And we have 4 ordered pairs. We're going to start with 2, 4. So in 2, 4, as we talked about before, the first coordinate, 2 here, represents the x-axis, 2 on the x-axis, which is the horizontal left to right line. And here we have 2. Let me go ahead and get out of this. Go back to the pencil. And then we have 4, which is on the y-axis. If I see 2 and 4, and I move up from from my 2 on the x-axis until I reach the 4 on the y-axis, and where they meet, it is my coordinate of my ordered pair 2, 4. So now let's go ahead and do the following 3 ordered pairs. Here we have 3, 6, 3, 6. Okay, class, let's go ahead and take a look at this example in a little bit more detail. So as you can see, I took the in and out table from the previous slide, and I moved it over. And the table represents the in and out of the corresponding terms, 1, 2, 2, 4, 3, 6, 4, 8, 5, 10. Now, remember, these are from your math message. And now, as you can see in my example, I was able to take those corresponding terms, turn them into ordered pairs, and then plot those coordinates. As you can see, 1, 2 has been plotted, 1 on the x-axis, and then 2 on the y-axis. And we were able to just connect those and find the coordinate, 1, 2. Again, this is a review of previous lessons, especially in Unit 4, where you were able to create graphs to then solve problems. Here, we're creating graphs to analyze patterns in our sequences. So now, once you've done that, you're going to take your your coordinates, and you're going to connect them with a straight edge. I apologize here because my straight line, or that is a little bit crude because of the tools. But again, let's go ahead back to what a straight edge is. This is a reminder, boys and girls, of what a straight edge is. It's any tool that helps us draw a straight line. It could be the edge of your notebook. It could be a ruler. It doesn't necessarily have to be one. It could be the side of a cereal box, just anything that will enable you to draw a straight line. So once we take our straight edge, we go ahead and connect the coordinates. And then now we're going to think about these 2 questions that I have below. Where can you see the +1 pattern used to find the in? So if we take a look at the in, 1, 2, 3, 4, 5 are sequenced there. We can see that we are growing. It's +1. So where can we identify this pattern on this graph? Well, the in is represented on the x-axis. So if I follow the sequence on the x-axis, I start with 1, then I go to 2, then I go to 3, 4, and 5. And I can see that the pattern is, it is growing by 1 on the x-axis, and I am moving by 1 to the right, from left to right. Now, where can you see the +2 pattern used to find out? The out column. So let's go ahead and analyze and study the out column. We have 2, 4, 6, 8, 10 on the y column, which means the axis is the vertical line here that you see going straight up. And here we have 2, 4, 6, 8, 10, and our rule was we were growing +2. So this tells me that as I move along the sequence of numbers 2, 4, 6, 8, 10, I can see that I am moving up 2 whole spots, as I move along my y-axis. Now, finally, in analyzing graphs, I want you to think about where you can see the ×2 relationship between the corresponding terms in the in and out. So, for example, where do you see the ×2 relationship between the corresponding terms of 1 and 2, 2 and 4, 3 and 6, 4 and 8, and 5 and 10? And what you should then conclude is that between each point is twice the distance from the x-axis as it is from the y-axis. In this example, we just took a look at the relationship between corresponding terms. We graphed points on our coordinate grid so that we could visualize the pattern and relationships, which we just did. Let's go ahead and take a look at some more practice problems that you'll be able to do. Okay, let's let's go ahead and take a look at number 2 here, practice problem. A rule is given at the top of each column in the table below. Use the rules to fill in the columns. So this table here to our right, in our in column, we see that the rule is +6. In our y column, we see that the rule is +y. Our first corresponding set of terms is 0, 0. So go ahead and follow the rules to complete the table. Okay, so here we have completed the table, and now we're going to go ahead and begin to analyze to see what's taking place in the table between the in and out corresponding terms. B, what rule relates each in number to its corresponding out number? So let's go ahead and focus on our first set of corresponding terms that we calculated here. We have 6, 2. Okay. So how does 6 become 2? Well, we can think of our 4 basic operations. We can think of multiplication, division, subtraction, and addition, and see how 6 could become 2. Well, since they're whole numbers, and we see that if we place 6 in and out comes 2, well, we know that we can't multiply, because when we multiply whole numbers, the product is bigger. Well, we know that we're not adding whole numbers because that is also true. So that leaves us with either subtraction or division. Well, 6 minus 4 is 2, so that's a possibility. Or 6 divided by 3 is 2, which is another possibility. So either subtract 4 or divide by 3. We'll only be able to be sure which is the rule if it applies the same rule to each of the other corresponding terms within the table. So let's take a look. Okay, as you see, the 2 rules that I've come up with, the subtract 4 or divide by 3, are the 2 that we're going to then test with the next set of corresponding terms, 12 and 4. 12 minus 4, okay? 12 minus 4, or 4 take away from 12, would give us 8. Well, we see that our out is not 8. Let's go ahead and try the next one. 12 divided by 3 is 4. So the second rule is still alive and well. And now we just have to test it with the 2 other remaining corresponding terms to see if this is indeed the rule. Let's go ahead and cross out the -4, or sorry, not -4, subtract 4. 18 divided by 3, okay? Yeah, that's 6. And 24 divided by 3 is 8. So this rule is certainly one that can be applied to this in and out table. So let's go ahead and we are dividing by 3. I'm just choosing to use this symbol here. You could go ahead and write the actual word divide by 3. Now, let's go ahead and graph these terms. But before we graph them, let's turn them into ordered pairs. And that you write them down in your notebook so that you can then think about how they would be graphed on the following coordinate grid. If you are toggling back and forth between your ConnectEd, make sure to also write them down so that when we move forward, you'll be able to plot them. Okay, here we are on our coordinate grid. So let's go ahead again now, and let's take those ordered pairs, and let's go ahead and plot them on this coordinate grid here. Okay, boys and girls, as you will notice, this is an example in the slide of our ordered pairs graphed. It's also an example of why you should use a straight edge when connecting your coordinates, because as you can see here, this line looks pretty sloppy. In any event, let's go ahead and review those ordered pairs that we just plotted. So our first ordered pairs was 0, 0, and you can see that we have that here. It's also known as the origin on the graph or the coordinate graph. Then we move on to 6, 2, the ordered pair, and we're going to go ahead and plot that by first going to our x-axis here, 6, and then looking at our y-axis 2, and marking the point where they collide. Then we're going to go to 12, 4, 18, 6, and then 24, 8. Once we've established our coordinates, we're now going to, again, we're going to visualize the pattern. What is happening in this graph, right? What is the relationship between x and y, which was formerly in and out? I want you to take a couple of seconds to go ahead and think about that relationship. Try and visualize the pattern that's taking place and what would be the next set of course or ordered, what would be the next ordered pair if this graph were to continue. Okay, when I take a look at this graph, I can see, when I analyze this graph, I can see that on the x-axis, if we start at 0 and then follow the next coordinate to 6, we can see that it has moved 6 whole places to the right on the x-axis. And that indeed is a pattern, because from 6 to 12, the same is happening, and from 12 to 18 is happening. And finally, from 18 to 24 is happening. So if we were to then move forward and visualize where our next number on the x-axis would be, we would go out to 30. Okay, let's go ahead and study our y-axis here and see what's taking place within our terms. So first, we see that on the y-axis, we start out again at 0, which is the origin. Then we have a coordinate at 2, a coordinate at 4, a coordinate at 6, and a coordinate at 8. We can see that we are moving up 2 whole places for each term on x. If we were to then extrapolate this information to decide what would be the next term on our graph, we would then know that the next term would be 10. So again, using this, we could then see that the next corresponding terms would be 30 on x, comma 10 on y. Okay, boys and girls, to conclude the lesson, let's just review our objective. So today, you were able to analyze in and out tables to identify patterns. We did that. And we did it so that we could then take that information, form ordered pairs, and graph the points on a coordinate grid to visualize, to make mind movies of the relationships between the in and the out of our corresponding terms. Before you leave, take a minute to see the extra activities that you could use to practice your objective or practice other skills relevant to 5th grade math. Okay, boys and girls, as a way to continue your practice, if you're logged onto your ConnectEd platform, you can continue with problem 3. If you're not logged on the ConnectEd platform, after this video finishes and you pause it, log into ConnectEd to the lesson of the day, which is 7.10, and go ahead to problem 3 on your pattern and relationships slide, and now continue with the prompts which we already did examples of in the previous slides. So here we have problem 3. Use the rules to fill in the columns. So you're going to go ahead and figure out your corresponding terms according to the rules. We're then going to move to slide 8. You're going to form your ordered pairs. And then we're going to go to slide 10, and you're going to take those ordered pairs and you're going to graph them on this coordinate grid here. And then once you're finished graphing them, then you're going to go ahead and try and visualize what is taking place. What are the patterns that are taking place after you have graphed your coordinate pairs and you have drawn a straight line through those coordinate pairs. Now, some other work that you could use to practice other math concepts. I'm first going to go out to my dashboard here. I can see 1, 2, 3, 4, 5, 6. And I'm going to look at the math boxes first. So I'm going to go ahead and click on the math boxes. Once I've done that, I can see that there are 5 different slides that correspond to the math boxes from lesson 7.10. If you have a notebook, then you can go ahead and do the problems here, pausing the video. I'm going to show you all 5 slides. So this is problem 1. This is problem 2. Problem 3. Problem 4. And problem 5. Again, if you have access to the ConnectEd platform, you can just go along at your own pace. And if for some reason you're having connection issues or do not, you can go ahead and pause this video in between the problems and perform the calculations on your notebook. Okay, boys and girls, this concludes our lesson 7.10. If you want to continue your exploration, you can go through all of these boxes at your own discretion. I hope you enjoyed today's lesson. Thank you for being here, and have a great day, and we'll see you next time.